trades. When you hit this number 7, don't just go, boosh, hit enter. Upper one, what's the upper one?
4.
Boosh, hit enter.
Uh,
That cool? Yeah, we don't need that darn trace thing anymore. Just put those numbers in. Hey, isn't that awesome now? So, what's the exact area?
21.3.
So, maybe we could write out a calculus formula for this. What is this really equal to? Riemann sums. How many rectangles would you have to build?
2. Oh,
Really, theoretically. I did 2, but theoretically, if you keep squeezing them, squeeze these tiny, thin rectangles, there's going to be less, what? Area. So, how many?
Infinite.
Infinite amount. What's the width going to approach?
0, almost 0.
You're onto it. What's the width of the rectangle going to approach? You're onto it. So what word do we have to use in calculus to say that?
Limit.
So how about this? You want to see the goofy math notation? What would it be? You say, okay, the limit. And if you want to know what page I'm copying this from, you'll see this on page like 374, right? The limit as n approaches, how many of them? How many rectangles? Oh, there you go. Okay. This is just math notation. We're on to this. And you go, okay. Summation. That means, by the way, everybody familiar with that? That's the Greek letter sigma. It means summation. Cool? I know. It's the Greek letter sigma. It means summation. They use the letter I. Don't let that bug you. They just decided to use I for index, And I equals 1. They said go to n because you're setting this thing to an infinite amount. Now, what's the area of rectangle?
Length times width.
Length times width. But regarding a function f of x,
Oh, x.
how about I call length f of x,
Uh-huh.
and then the width just change in what? Change in x. Does that make sense? So here comes my length times width. Ready? Length f of x. Width
Change.
change in x. Now, the author put a subscript I here because he's trying to tell you you're going to sum an infinite amount of these. Like x sub 1, x sub 2, x sub 3, x sub 4, x sub 5, x sub 6, x sub 7, x sub 8, like x sub a million, x sub a trillion, you know what I mean? And this turns into, let me put an equal sign, ready? Da-da-da, 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 that cool? Now you have to go from some what? Some certain value to what? Does that make sense? Now here's everyone, you want to write the rest of the wording from this? If S is interval on interval A to B, you gotta make sure there's no what? Holes in your function, right?
Continuous. Okay.
Yeah, a continuous function. There it is. That sound good? Oh, again, Amber, if you like this, what would change in X represent? What would change in X represent? B minus A over this what? This N. But I'm using an infinite amount. Cool. Hey, last problem. Let's do application. Sound good? I think you'll love this on a test. I'm going to have you do something, real life data. Not some goofy thing like this. But real life data. So I'm going to 5.1. Let me look for something good. Come on. They got a motorcycle. They got a runner. That's it. And when they gave the speed of a runner in number 13, they gave a motorcycle in 14. All right. Everyone, can I take number 14 and reword it in some way and see how you do with it?
Okay.
All right, here you go. Can I erase this? You sure? Hey Josephine, I liked your question earlier. Like, is there a way? This will always tell you how many you make for each, and that's your width every time. By the way, same thing in Calc 2, and as you go into Calc 3. You can remember that. B minus A over N. The only thing is, Josephine, in Calc 2 you may have 2 of these. So you do a B minus A for that one, and a B minus A for that one. That's the only difference. I think you all will like Calc. All right, here we go. Here's the table. They give you velocities. 0, 12, 24, 36, 48, 60, 30, 28, 25, 22.
24, 27.
Now, I want to make sure I can ask this question on a test. Did you notice it went back, kept going back up?
Uh-huh.
So I would do this on my test. I'm going to change these numbers if you don't mind. I'm going to change the actual velocity of this motorcycle. 10, 5. The only reason I wanted to do that, Art or anybody, if you're curious, is because I want to ask a question about the overestimation or the what? Underestimation, okay? If those original numbers are there, you've been, hey, I don't think there's enough information here. Does that make sense? I want to make sure you could see, oh, this graph kept going, so you could see if you got over or under. So, letter A. And I want you to use a left Riemann sum with 5 subdivisions. And then I would say this, just so there's nothing ambiguous about this, with equal length. The subdivisions have equal length. Okay? And I want you to use a left Riemann sum with 5 subdivisions equal length to estimate, here we go. Ta-da-da. Ta-da-da. This thing, it may be bothering you right now, then that just means I'm using the letter T with respect to T, okay. Be a T, and I want you to go from T equals 0 to T equals 60. Now would you try it? Now I'll be honest, it never said you had to make a drawing, but a lot of you will probably on my test make a what?
Correct.
Probably draw it. Yep. Sorry, yeah, that 0 looked a little goofy. Hey, when you do this, and I ask a couple questions to follow this. When you do this, I think a lot of you will make a drawing. Because on the left, right, where's the curve, right? So what would you do? Oh, you just go over here to the side, right?
Mhm.
Just go like this. Doesn't have to be perfect. Go like this. Go like this. This is T. This is what?
B.
B of T. Now, what did the T's go by? What were the increments? 12, 24, 36, 48, and 60? I actually love seeing these, but doesn't mean you had to. It never said draw a picture, right? I think it helps. Well, let's estimate these. How high was this?
30, that's 0.
So that was at 30, and then how high was this?
28.
I like to label them, 28, it's got the 25. Look, I'm just estimating, can you tell?
Mm-hmm.
Claire, I'm like, that's about 25 in height. I see it's going down, what's this?
24.
22, 10, and what? 5. Does everyone see? I was just estimating the heights there, right? It doesn't have to be perfect. And then I connect it with my pencil. It looks kind of, yeah, look. It's just a little curve. Not perfect though, but I think drawing these helps. Because you know what's coming up. Letter B. Is your following answer an overestimation or an underestimation? Of 0 to 60, B of T. Now you see the importance of Riemann sums. Sometimes in real life, this is all you have.
Professor, are you going to say is this an overestimation or underestimation from left side or right side? Do you have to mention that or that?
I would say, I would follow this question up after I did a left.
Oh, left, okay.
And I should, when I write this, I should be more clear, but I'll be indicating that last answer.
Okay.
So just remember, when I say is this, I'm talking about your last answer. where we did a left.
Does the formula you said B minus A over N work?
And that will give you the width of each what? Rectangle. That will give you each width, so try it. What's B minus A?
Well,
B minus A is 60 minus 0 is 60, but what was N? 5. So let's try that. Josephine, we're going to try that formula to find out, well, what's going to be the width of each one of these. B was 60, A was 0, 60 minus 0 is 60, 60 divided by 5 gives us what number?
12.
12. So that means every 12 I'm going to build a rectangle. Does that make sense? You got it. I can go off to the side. What was that again? Change in this what? X. Well, in this case, what's the letter?
T.
So that means for every 12 I build a what? Rectangle.
Rectangle.
Now I have a question. Belraj, that works every time. Josephine, that works. Raise your hand though if you just kind of do this logically. I bet a lot of you just, like you, I think I follow you. That's totally fine. You just go, okay, I need 5. You're like, 1, 2, 3, 4, 5. That's totally fine. I get a lot of students that just, they don't have to do this math here because they can see in their eye, if I need 5 of these, and they're equal length, then I'd have 1, 2, 3, 4, 5. 5 rectangles, 5 subdivisions. But yes, always works. Every time, Belraj. Every time. So now, which side am I building this with?
From the left, right? So from 0.
All right, here we go. Why is this important? Because everyone, when I do my LW plus my LW plus my LW, I'm telling you, I get more errors on this problem than the complicated calc problems. Because people try to do it with no picture. They just go, oh, it's just those numbers in the table. But you got to be careful. Which length am I using from that first number? Can you see it? Like the width is what? 12.
12.
What's that length?
30.
30. All right, so here we go. What's the next one? Maybe I should draw it. Can you see it?
Mm-hmm.
Do you see that, Amber? How I'm really thinking like left side, stop, cut over, right side. So this length is 28, isn't it?
Mm-hmm.
What's the width though? Not 24.
12.
I see this on tests all the time too. Look at that. That's not right. What's the width of that rectangle? It's that number, Belraj, you told me. You said that change in X is 12. You always use 12 for your width. That's the width. Now you see a pattern to this?
Mm-hmm.
30, 28. 28, what's the next one? But Aaron, sometimes students go too far and they go to the 5. Don't go to the 5, it's just gonna go to what? Trust me, I know there's people in this class, you get really fast at these. I think that's awesome. I just always say what? Be careful, right? Be careful. Is this what's gonna happen? Because look at the last one. Just take the time to draw these.
That's an overestimate.
Everyone, did I ever use this 5? But if I used a right Riemann sum, I would have. Do you agree?
Mm-hmm.
Now think about it. If I did a right Riemann sum, I would have used a 5, but I wouldn't have used the...
30.
You got it. You got it. That's what I mean. If you start doing it, people do this without even drawing pictures on tests. Just be careful. Now, I don't know what this is. Did anybody try?
1380.
Oh, thank you. 1380, huh? Now, letter B, over or under?
Over.
But be careful on the here, I'm just going to circle. Be careful on the test. I might have the data go like this. What do you think it would be if I did a left Riemann sum? Yeah, all right, good. But what I couldn't do is I couldn't make it go up then down. It wouldn't be enough. And then letter C. That's a good note to end on. Ready? This was velocity. The units, everyone, for this problem were in seconds. So I got to point this out. Time was in seconds. Velocity
Feet per second.
was in feet per second. This was a motorcycle. Letter C, I'll write this out if anyone wants a copy, you've got a minute. And when using correct units, make sure you use correct units. Explain the meaning of your answer in letter A, the meaning. And I think a lot of you will get it. What does that number mean in terms of this real life problem? What does it find? In letter A.
So position.
All right, everyone, those are velocities, huh? And we summed all this. But we're doing what? Antiderivatives. And today we went from acceleration to velocity. And when we did the antiderivative of velocity, we get back to what? Position. So in terms of real life application, what is this 1380 representing? Not the position of it, but the total what of that motorcycle? The total
Feet per second.
distance.
Feet, yeah.
The total distance that that motorcycle traveled over how long?
60 seconds.
Someone, take some time to write this before you leave. You'd say, this represents the total distance that the motorcycle traveled over the 60-second period. But don't say, hey Amber, don't say feet per second, because it's distance. It would just be in what units?
Feet.
So you would say, how many feet would this be? The bike roughly traveled how many feet? Like, put that in words. This motorcycle traveled roughly 1,380 feet over the 60 seconds. Does that make sense? So hey, I'm gonna be careful right before I leave. What if I did like flow of oil out of a tank? And we did the same thing.
So
So I
liquid.
give you all the rates of the oil. It was flowing at like 32 gallons every hour.